Hello, friends and students. Welcome back once again. Today we will start or we will see one new topic: how to understand a data sheet of electronic component and devices. This topic is important. Why? Because when you go to industry or when you want to work in an industry, in any of the factories, like big companies and all, where they use components and devices, so they want that you should have complete knowledge about the components, or if you don't have, how can you check the data sheet provided? You should be able to see the data sheet. Sometimes the data sheet may be very lengthy, but what are the special or what are the specific things what you have to check in those data sheet about your components or your boards or your devices? That we are going to discuss in today's video. Okay, right. So I will just go to the slide. You can see here. I will just go to the slide here. What does a data sheet does? It gives you the complete information about the part. Data sheet provides a detail, right? Details analysis working of that particular part. So what you will do, so what you will check: general description about the part, pin configuration, function of the part, electrical characteristics and electrical specification of the part, package information, and environmental and anyhow. So we'll go to the next slide. How you will use the steps, like how you will check the data sheets. First of all, you have to understand your application. Identify the key requirement like voltage, current, power, and frequency before reading the data sheet. That means if you are working on any project and you are using that component, what is the circuit, why the circuit has been used, and what are the components, what is its requirement of that particular part in that circuit, that analysis first. Second, focus on critical parameters. What are the parameters required for your circuit so that it will work properly? That you have to keep it in mind. Third is cross reference with alternatives, right? What are the different other alternatives you have for that if that particular component data sheet is not available? Then use manufacturing tools. For what purpose you have to use? Design tools like software for earlier integration of their components. Say if you are using a microcontroller, so use your manufacturer's tool that is a better and work fine for your microcontroller program, right? So these tips you have to keep it in mind. Second, example of this I will give you here. We have taken an example how you will check the things and all in the data sheet. So we have taken a component that is LM7805. It is a voltage regulator. What is the general description about this? It provides a fixed 5-volt output with up to 1 amp current. This is very important. Up to 1 amp current. 5-volt output, 1 amp current. Maximum rating, that is absolute maximum rating, is 35 volt. You cannot give more than 35 volt to the input of this particular IC. Dropout voltage is 2 volt typically. Application circuits input capacitance is 0.003, that you have to connect. At least 0.1 microfarad are required to stabilize the operation, right? So in pin number 3, in pin number 1 of this regulator IC, you have to use this application so that it functions properly, right? So this is just an example. What you have to see: what is the importance of data sheet in industry? Component selection. When you select a component for your schematic or circuit, it is very, very important, because without data sheet, you will not know the complete information about that particular part. Design and integration. Engineers use data sheet to design circuits and ensure components are used within their operating limits. How you will come to know about the operating limits? Because in the data sheet, everything is given. Troubleshooting and testing is a very important part. Data sheet helps you diagnose issues and very correct operation, because all the details will be provided in that particular data sheet. Cost and sourcing, you will come to know about the cost and where to get it, who is the manufacturer. These all information you will get with the help of data sheet. Reliability and safety, ensure component meet standard and operate safely under given condition. So all these parameters are very important for the industry. Please remember, no college, no organization, no institute will teach you all these things. But I'm telling you, since I have experience in that, so you have to remember these ones. So what we will do is, I will just go to a few of the data sheet. I will show you, and we will discuss about that, so that you will get idea of what you will be looking. All right, now you can see in this data sheet I have opened. This is for a very popular transistor that is called as PC547. Okay, so what you have to, it is manufactured by Fairchild, is the name of the company. this data sheet has been published in the year 2014. So what you have to see, first you can just check it on the top. There's 546 PC, 547, 548, 549, 550. So these are all the transistors which are equivalent to PC 547. So first you came to know what are the equivalent transistors for this. Come to the next line, it is given NPN exponential silicon transistor, right? What is exponential means the layer inside, silicon layer inside, it is on the top of each other, like they will be made equal length and it will be fixed with that. So it's a silicon transistor. What transistor? NPN transistor. Now come to the feature. Come down just below this small letters. It's given. What purpose? What is the purpose of this transistor? Switching and amplifier. That is, these are the two main functions of this transistor where it is used. It is switching and amplification. Up to what volt? That is VCO voltage, right? Collector emitter, it's VCO or VCC voltage maximum. It can work up to 65 volts. Okay. Low noise. That means if the low noise reduction is there, 549 and 552, these two transistors are better selection. Come to the little right hand side. It is given TO92. This is nothing but what is TO92? It is package. What package? TO92 is the number and the number package it is given. So you will come to know about the package. Why? Because why package is important? Why? Because it will tell you when you design a PCB and you want to fix this transistor on the PCB. So this will guide you. This complete data sheet will guide you. What should be the spacing? What should be the pads? How the pad should be there? Everything this will be giving it to you, right? So that's why package is very, very important. We'll go to the next section of this. Okay, here you can see it's a current rating. We have just discussed the maximum is 65, right? 65, like DC 546, the value is 80 volts, 80. We can go give up to 80, but the standard value is 65 volts. Okay. Second part is the current, collector current. Okay. So you can see collector emitter, the collector DC current will be there. It is approximately how much it is? 100 milliamps. The next comes with the power. So first we have discussed about voltage. Second is current rating, and third is power rating. How much is the power rating? What is the power rating? 500 milliwatts. So wherever you want output to be more than less than this, there you can use this particular transistor, right? 500 milliwatt. Physical dimension, like I said in the beginning, not this. This is the physical dimension. Okay, TO92 package. I told you why it is important, because when you are designing a PCB, at that time you will get this information, or you can put this information for the in that particular software, so that the holes, the pads, and everything are made perfect. Okay. So this is one part. This is about the transistor. Okay. I hope you understood this. I will explain you about the other part. All right. Now you can see here. Now next example I have taken as a timer IC. That is any 555 or SE 555 IC. Okay. So first pin configuration description is given. Okay. You can see the description here on the top. That you have to go through it, where it is used, why it is used, how many pins are there, everything will be given in this particular. Please remember, ICs and all, the information or the pages of datasheet will be more, but have patience, not to worry. The important thing only you have to understand. The first thing is, what is the name of this particular part? How many pins are there? What are the features of this particular part? Feature you can go for. What is the application of this particular part? Next, I will go to the next slide. That is, right? That is block diagram, right? Pin diagram, we can call it as a pin diagram. Here it will be telling you what is there inside the IC and what is, how many pins are there and what are the function of those pins. Okay, this information you will get in this particular block diagram, right? Then comes to the voltage rating. Okay, so here you can see the voltage rating maximum is 18 volts. You can see here on the top, 18 volts is the maximum rating, and the current rating. Okay, the current rating, the temperature, we are not that bothered about the temperature, and current rating should be approximately 600, 18 volts, or we can say it's a power rating. Power rating we have to take it. Power dissipation should be 600 millivolts. It's already given millivolts. So these are the parameters what you have to take it in consider as an this thing. Okay. So other parameters you can see DC and AC electrical characteristic. You can see the same thing it has been given. The minimum voltage, the maximum voltage and minimum voltage. That is minimum is 4.5 and maximum you cannot cross 16 volts. That is characteristics. Okay. The supply current should be 3 milliamps and maximum should be 15 milliamps. You can see from 3 milliamps, 15 milliamps. So these are the things what you have to check. Okay. So this parameters. There are so many other things charts and all. If you want to see, you can change. So if you want to see what are the triggering pulses into the input changes and output, what is the pulses you get, all everything will be given in this. Okay. So these, whatever the parameters I told you, you have to see, check those parameters. Put one more IC, that is a microcontroller IC, that is called, that is the number is Atmega 328P. This is very popular IC. Okay, we'll discuss about this Atmega 328P. It is used in Arduino boards. Please remember, Arduino boards microcontroller. This is the Atmega 328P. Okay, it is AVR family microcontroller 8-bit computer. Okay, so here what you have to see, here you have to see the complete features about the complete this thing. In the introduction, it will tell you what is the details about this feature you have to study. I told you in the beginning. Okay, features you have to study, and what else you have to see? You have to see one more thing here. You can see operating voltage over here. Okay, operating voltage is 1.8 to 5.5. That means your IC voltage, supply voltage should not exceed more than 5.5 volts. So when you give USB supply, it will be this thing. But when you give V input on the Arduino board, you can go up to 20 volts also, 18 to 20, because what it will do, that board on the board, that is your Arduino board, it will have a regulator there on the top of it, that is 3.3 volts regulator will be there, or 5 volt regulator will be there, which will reduce that 20 volts to 5 volts, and it will give 5 volts to the particular Atmega 328 IC. So this is about the ICs. What your this descriptions are very big. You can see so many this thing. This is the one square type of IC. That means same type of IC. You get it in square shape, in different shapes and all. Other points you have to, you can just check it out. What are the descriptions about it? How to, when you, this particular, this thing is important when you go for the PCB design. Okay. So likewise, you can just study about it. But main important, what are the main important points that I have told you? Okay. So if you press this, it will give you what are the Atmega 328P, what are the different ICs and all, and how many pins are there in that particular IC. It's a AR family, AVR family. See, here the complete, it's a 28 pin. Okay, 28. That is, we call it as a pin configuration, pin diagram. Okay, so this is few of the points you have to keep it in mind when you check the ICs. Okay. It is used in Arduino boards. Please remember, Arduino boards microcontroller. This is the Atmega 328P. Okay, it is AVR family microcontroller 8-bit computer. Okay, so here what you have to see, here you have to see the complete features about the complete this thing. In the introduction, it will tell you what is the details about this feature you have to study. I told you in the beginning. Okay, features you have to study, and what else you have to see? You have to see one more thing here. You can see operating voltage. All right, friends. So finally, I will just tell you about this particular Pico 2 and Pico 1 and Pico 2 boards. Here we are using IC 2350, and previously Pico 1 we used to have another IC. So very popular board nowadays, right? You can just download the complete documents of this particular board, because in the coming future we will be doing some practical based on this board. So I'll show you some practicals based on this board. Okay. So what are the features when a microcontroller? 4 MB flash. You can see here in the top bottom it is given 4 MB flash. Okay, micro USB port is there, right? It has a 40 pins. It has approximately 40 pins. Works with the function. Works with the voltage that is 3.3 volts. Atmega 328. We are just now we have seen it was working with 5 volts. But here it the previous microcontroller 8051, 52s and all, they used to work with 5 volts, minimum 5 volts and all, right? If it is less than that, it never used to work. But now there's the other ICs have come up which works with very little this thing. Okay, it is what the type of you can see the complete details over here. I'm not going to explain you about these things and all. You can directly see. But what I'm trying to do, why the data sheet is important? Why? Because the complete information you will get from the data sheet. What you have to see: features, application, package, block diagram, right? Maximum voltage, minimum also you have to check. Then current, that is, and power. These things you have to do. If you're a designer, you design a PCB, then you have to see for what the board outline or board topologies. Okay, pin description and board topologies. These things also you should inform.